So this is my code for the K nearest neighbors problem. Here I just read in the book label CSV to get the names of the books. Here I read in the data CSV row by row, and I use this information to construct a matrix that's users by the books, and then for each user and book it has the user's rating for that book. This is the Pearson correlation coefficient calculation, which is based on the Geeks for Geeks example, but I added this conditional that basically says it makes sure that both users being compared in this function have a rating for the target item for T, because if they don't, we don't want to include the user. And then the KNN function uses this Pearson correlation coefficient function to calculate the correlation coefficient between our target user and each training sample. And then we take this matrix of, this matrix of correlation coefficients and sort it in decreasing order so that we can get the top or the nearest neighbors. So for whatever k value was passed to this function, we want to get that many neighbors. So here I'm basically just indexing the correlation coefficient for the highest ones to get the associated user. In the rating prediction function, I run the KNN function, and then I'm basically trying to average all of the nearest neighbors' ratings for a given book to try to find, or to try to predict that rating for the target user. So for each of the nearest neighbors, if a rating exists for item T, then I add it to the average, and I'm also counting how many elements I have in that average in case some of the nearest neighbors don't fit in. And then so if average comes out to 0, so if none of the neighbors have a rating, then we calculate the average of all of the training tests, or all of the training samples ratings. For the recommendation function, I'm storing everything in a dictionary, and so for each book in this user's record, I want to find a recommendation for all of the books that they don't have rated. So here I'm running the prediction rate for a given book that I'm trying to find a rating for you, and I'm storing the book with the predicted rating value, and then I'm just returning the books with the highest predicted rating. And then for my mean average error for the test samples, basically what I'm doing here is I have an array to store a prediction for each element, and then if the user has a rating for this book, then I add it to the average error, and then I make a prediction for the book and I put it in its proper index, and then I subtract this predicted array from the actual array and I get the absolute value. So for the 10 most similar neighbors, this would be for user 35, the 10 most similar neighbors. These are the nearest neighbor users in decreasing order of similarity. So for predicted ratings, for user 35, for book 0, our predicted rating is about 1.5. So to recommend the top 3 items for user 35 with 20 nearest neighbors, we get the following. So these are the books actually being recommended, and then down here is the actual predicted rating. To calculate the mean average error for k equals 5 nearest neighbors, this is our mean average error.